Hello and welcome to the continuation of our lesson on numbers. Alright, so we looked at a few things, right? In the last lesson, we looked at different types of numbers that we have, which are the int and the double. Okay, we looked at passing strings into numbers, and I said we are going to look at properties and methods of numbers today. So we have the following properties, all right, and I'm going to look at a lot of them, probably not all of them, all right. So I would like to start with this is finite. So this is the syntax for it, and they said the property returns a Boolean value true if the number is not a number. All right, this NaN simply means not a number, or positive infinity or negative infinity. All right. So remember I said that integers in this definition, right? I said that int refers to integer of arbitrary size. Arbitrary size meaning that every integer has a size. Right? No integer is infinite. Infinity is a value that is never going to be reached by any number. Alright, so every single integer has a size, no matter how big, no matter how small. Okay, so because of that, every integer is, in fact, every number is finite. Alright, so if I were to run this code, edit and run, you see that I'm going to have true because 5,000 is too small not to be finite. Right, it is finite. I don't know what this number is going to be, but no matter how big we make it, no matter how many zeros, it is still finite. The integer literal. Okay, this number is actually too big to be stored in this data type, so they say I should use big int instead. So let me see if this works in that. Integer literal tries to make it if you need. Okay. Let me do something. I'll ask ChatGPT, what number is this? Five nonillion. Wow, I've never heard of this before. Okay, let me reduce it. But then even 5 nonillion is finite, alright? At least it didn't write for us here. It gave us error warning. So let me just do this. Value of type int. Still saying this is too big. Sorry. Okay. So all integers are finite, alright? Meaning that every integer has, in fact, every number has a size. And then we have this is infinite. It says the property returns a Boolean value true if the number is ANAN. In other words, if the number is not a number, or positive infinity or negative infinity. Alright, so if you have anything that is not a number, it might just return true if you do is infinite, else to return false like this one did. All right, so I still have my my IDE. If I come here and paste this, I'm going to have false because it's actually finite. All right, so all numbers are finite. Is NaN is not a number. It says it returns true if the number is the double, not a number value, otherwise false. Now, of course, we know that all numbers are numbers, right? So if we do is NaN here, I'm going to have false because it's actually a number, and this is NaN, means it's not a number. Okay, so which number will then give us true? Like, what will give us true exactly? What value will give us true if we do is NaN on it? Something like 0 over 5,000 or 0 over any number. Let's start this with double. Alright, so 0 over 5,000 I believe is, wait, what is 0 over 5,000? 0. Okay, what is 0 over 1? Okay, I'm thinking of something. Let me say 0 over minus 1 minus. Alright, so we still have a double. Alright, we still have a double. So all numbers are finite, right? And all finite numbers. Sorry about this. And all finite numbers. All finite numbers are, of course, they're actually numbers. So let's just look at these other properties. Is negative. Now, you know when a number is negative and when a number is positive, right? Right, if a number has the minus sign in front of it, it is negative. If a number has the plus sign in front of it, or if it doesn't have any sign at all in front of it, is positive. Okay, so it's very simple. If I added in minus sign here and I say it's negative, of course it is negative. All right, so we'll have true here, otherwise we'll have false. Okay, so we also have this dot sign, and what it simply does is it returns -1, 0, or +1 depending on the sign and numerical value of the number. So this just tells us the sign of any number, right? So like when I had minus here, if I did is sign, sorry, if I did dot sign, n dot sign, all right, I'll just have -1. But if I had, if this were positive, all right, and I did n dot sign, I'll just have 1. Or if this is 0, I'll just have 0. All right, so that's just what it means, nothing else. And then I believe I don't need to explain what is even and is odd means, right? This just returns true if a number is an even number, and this returns true if the number is an odd number. All right, so that's what it is. Now let's look at the methods for numbers, for manipulating numbers. All right. The first one we have is ABS method. right? And it says this property is used to return an integer representing the absolute value of a number, right? Now, if you know what absolute value means, right? Absolute value of a number is just we are looking at the value of a number irrespective of the sign, irrespective of whether it is a positive or a negative number, the value that that number has. For example, the absolute value of minus 1000 is 1000. All right, just the same way the absolute value of plus 1000 or 1000 is still 1000. The absolute value of minus 99 is 99. Okay, so this is just it's common knowledge. All right, what absolute value means. So, but here it says this is used to return an integer representing the absolute value of a number. So that is what it essentially does. All right, if I have 303 here and I do n.abs, I'll still get 303. Sorry, it's a method, so I will need to add this parenthesis, okay, because it is not a property. Right, so when we talk about properties, when we use properties, all right, we don't need to attach parentheses at the end. But here we are talking about methods, all right, and for methods you have to introduce these brackets at the end. So n.abs is actually 303, and it's the same value even if 303 is negative. All right, so that's just all there is to it. .co, I like to call this ceiling, and it actually means the same thing, right? .co. So this property returns the ceiling value. All right, that is the smallest integer greater than or equal to a number. Okay, so for example, 2.4.co is 3. In other words, the greatest integer, the smallest integer greater than or equal to a number. All right, so that's just it. And then we have dot compare to. This compares to other numbers. Now we saw dot compare to under strings, right? When we had well, you can, if in case you forgot, you can go back and look at it. All right, but this compared to simply compares to values. Right, so right now I am comparing 3 to 5, and since 3 is smaller than 5, what am I going to get? Minus 1. All right, because 3 is smaller than 5. The number I am comparing another number to is smaller than the number I'm comparing it to, so I get minus 1. All right, if I use a bigger number here, it's going to be 1, and if they are equal, it's going to be 0. So that's just simply what it means. That's all. All right, dot floor. So floor returns the largest integer less than or equal to a number. So this is just like the reverse of .co. All right, so 2.9.floor will give us 2, whereas 2.9.co would have given us 3. 2.9.floor, the floor, right? Just consider it as ceiling and floor. The ceiling of a building and the floor of a building. The ceiling of a room, all right, and the floor of a room. So the floor of this number is 2, which is the largest integer less than or equal to it, and the ceiling of it is 3, which is the smallest integer greater than it or equal to it. All right, so that's it. And then we also have remainder, which returns the truncated remainder after dividing the two numbers. Let me see how this is used. Number dot remainder x. Okay, so this is it. This is simply what it means. If I do 8 dot remainder 4, let me see what I get. Okay, because 8 divided by 4 is actually 2, remainder 0. But let me do 3. Yeah, I'm getting 2 because 8 divided by 3 is 2, remainder 2. Alright, so this just performs this division operation between these two numbers and gives us the remainder here. Alright, it just returns the remainder. So that's what it does. And round returns the integer closest to the current numbers. Okay, so that's round. Let's see. Okay, I get it. So let's have a double, like what number now? 10.2. That's round. Alright, so what I'm just going to do is I'm going to get the approximate value of 10.2. Alright, the approximate value of this number is what I'm going to get. So, and it's 10. Alright, if I say 10.8, that's round, it's going to be 11. So it just rounds up 10.8, or it just rounds up my decimal value. Alright, and you know what it does? It gives me the approximate value of the number. Next is to int. Alright, so what this does is very simple. It converts, if I have a double, right, and I do the double, in other words, n1 dot to int, it will just give me this number in an int format. Alright, so this is just how it works. Let me still use, okay, let me do 10.0. If I print 10.0, I will get 10.0. Alright, but if I do 10.0 dot to int, I'll get 10. But if I try to do 10.3 dot to int, okay, I'll still get 10. Does it round it up for me? Let me check. No, it doesn't. Alright, so this is actually flooring 10. Okay, so next is to double. Alright, so to double does something similar. 10 dots to double will give me 10.0, and so on. Alright, to string does the same thing. It converts your number to string. Alright, so this is what it looks like. So I have this variable n1 initialized to 2, right? If I do n1 dot to string, now this I'm going to come to this anyway. This value dot is string now checks whether this value is a string, right? If it is not a string, it will return false, but in this case it returns true because I have converted n1 to a string. All right, so that is what it does. And then truncate, It returns an integer after discarding any fractional digits. Okay, I believe we have looked at something similar to this, right? So this is just, this is similar to floor, all right? So it just returns this value without the decimal, all right? It just returns the whole number. That's what it does. So n1.truncate is going to give us 2, right? It truncates 2.123 to 2. So that is what it simply does. So that is, these are the properties and methods we have in integer, in numbers, all right, both integers and doubles. So I will encourage you to go through these websites, tutorialspoint.com/taskprogramming, and find this section, numbers, and read it up yourself, and you can practice on your own too. All right, and we'll see you in the next class. Thank you.